D block element? Because the last electron which enters to the D block. Hence it is known as what? D block element. Why it is known as inner transition element? Because it present inside the D block. Hence it is known as what? Inner transition element. 3D series which are having the atomic number from 21 to the 30 and it has a subshells of 3D. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to start with a new unit called D and F block elements. So, before going to deal with this unit, let's see the weightage of this unit. So, from this unit, we can expect 3 questions. From the part 2, the question number 14 that carries 2 marks. And from the part C, question number 23 and 24 which carries 3 marks. So, total weightage will be 8 marks from this unit. So, we can easily get 8 on 8 from this unit and it is very easy to score 8 on 8 from the D and F block elements. So, let us see what is a D and F block elements, where it is situated in a periodic table. Let us understand now. Okay. So, in this session, we are going to discuss with the introduction and we are going to understand what is a transition series and we are going to understand mainly about the electronic configurations of the D and F block elements and we are going to understand some of the important characteristics of the transition element. Okay. So, we are familiar with the periodic table. Is it right? Yes. In a modern periodic table I am talking. So, the elements which has been grouped into 4 blocks which are named as S, P, D and F. Is it right? And I can write that small picture for you. This is my S block. Similarly, I have P block. This is P block. So, group 1, 2, 3 to 12 and 13, 14, 15, 16, 17 and lastly 18. Okay. And we have 2 sets of this one. This is lanthanides and actinides. Is it right? You can see this picture and clearly understand that in a modern periodic table, entire periodic table has been divided into 4 blocks. They are S, P, D and F. We know that the group 1 and group 2 elements are together known as what? S block elements, and the group from 3 to 12 they are known as what? D block elements, and the group 13 to 18 we call it as a P block element, and the last 2 groups which is kept below in the periodic table which is known as F block elements. So, more about this D block as well as with the F block we are going to understand in this unit. Okay. So, the element which is belonging to the group 3 to 12 in a periodic table, they are known as what? D block element, and it is also known as what? Transition element. It is also known as what? Transition element, whereas F block elements are also known as what? Inner transition element. Inner transition. It is also known as what? Inner transition element. Okay. Then the elements which possess partially filled D subshell either in the atomic state, either in the oxidation state, they are known as what? D block elements. Do you know why they are called as D block element? Because the last electron which are enters to the D block. Hence it is known as what? D block element. Similarly, the F block elements are also termed as F block because the last electrons which enters to the F block, hence it is known as F block elements. So I'll explain that why it is known as D block and S block when it is dealing with the electronic configuration. Okay. Now you can see that this is an entire complete picturization of the modern periodic table. It consists of 7 periods and 18 groups. Okay. So we are familiar with the group 1 and group 2, which is together known as what? S block element. And again we have from the group 3 to group 12, it is known as what? D block element. And we have from the group 13 to group 17, they are known as what? P block element. This is the last group 18, which is known as what? Noble gases or inert gases, because it does not react with any other element. When I am talking about this D block element, here the elements has been started from scandium to zinc, then the scandium to the zinc, and till it will end with the elements which are having the atomic number of 112. So this sets of elements are known as D block, but we have 2 special cases here. So the elements which are having the atomic number 57, okay, the elements which are having the atomic number 57, which shows a similarity with other 14 elements, hence it is kept below in the periodic table. You can see that after lanthanum it is cerium, it is 57, 58, 59, 60, 61, 62 up to 71, which is nothing but a lutetium. So this series, which is known as what? Lanthanum or lanthanoid series, which is known as what? Lanthanoid series. Like that, we have one more element known as actinium. So which shows a similarity with other 14 elements. You can see that 89, 90, 91, 92 up to what? 103. So it will start from actinium and end with lawrentium. Hence this is known as actinide series. Actinoids or actinide series. Like this, you know, the D block elements which is further classified into 2 groups, hence which is also known as what? Inner transition element. Why it is known as inner transition element? Because it present inside the D block, hence it is known as what? Inner transition element. So hope you have understood that how I have picturized the D block, which consists of all metals. Okay, in that 2 metals, especially the lanthanum and actinium, which shows a similarity with other 14 elements, hence it keeps below in the periodic table and it is named as lanthanide series and actinide series. Both the lanthanide and actinide series together known as what? Inner transition element, because it present inside the transition element, okay, or in the D block. Next, the D block elements are also known as transition element because they change their property between S and P block. So when we are dealing with the D block element, you can clearly know that the D block which is present between the S and P. Is it right? Hence it is known as what? Transition element. It shows its characters between the S and P. Hence it is known as what? Transition element. Between the electropositive S block element to the least electropositive P block element, hence it is known as what? Transition element. But the copper, gold as well as with the silver are the transition metals because of their commonly occurring state and they have partially filled D subshells. But we have exceptional cases here, that is zinc, cadmium and mercury of the group 12, they do not have partially filled subshell in their elementary status and commonly occurring oxidation state, they are not considered as a transition element. Here you can see that in a group 12, the zinc, cadmium and a mercury, even though it is belonging to the d block, it do not consist of half a d orbital. Hence, it is not considered as a transition element, but even though it is present in the d block. Okay, that is the one exceptional cases, because those elements, it do not shows the electron which is present in that d block. That is why they are not considered as a transition element. Next, again this a transition series which is further divided into 4 series. They are referred as 3D series, 4D series and 5D series. Again we will go back to the periodic table to understand this. So the first series from the atomic number 21 to the 30, which is known as what? 3D series. Which is known as what? 3D series. Similarly, the atomic number 39 to the 48, which is known as what? 4D series. Okay. Similarly, the lanthanum, which is having the atomic number 57, which is 5D series. Similarly, the actinium, which is known as what? 6D series. Like this, transition series also, which is divided into 4 types. They are 3D, 4D and 6D. Okay. The 3D transition series, which consists of the element with the atomic number 21, that is scandium to the zinc. Okay. Which are having incomplete 3D orbital, hence it is known as first transition series. Whereas the 4D transition series, it consists of the elements with the atomic number 39 to the 48, which is from yttrium to the cadmium, which is having incomplete 4D orbital, hence it is also known as what? Second transition series. Similarly, we have 2 more transition series, that is 5D and 6D, which consists of the elements which are having the atomic number 57, that is from the lanthanum to the mercury, and which is having incomplete 5D orbital, hence it is known as what? Third transition series. Similarly, we have 6D transition series, in that the elements from the atomic number 89 to the 104 or to the 112, which is known as what? 6D series, which consists of incomplete 6D orbital, hence it is known as what? Fourth transition series. Like that, the transition series are further divided into 4 different series, that is 3D, 4D, 5D as well as with a 6D. Now let us see what are the general electronic configurations of the first series. Okay, because in this chapter you are going to understand more about the 3D series of element. That is why I am discussing with the 3D series of the element with the electronic configuration. So when I am talking the general electronic configurations of the D block, we must understand what is the general electronic configurations of the D block element. So the general electronic configurations will be written like this: general electronic configuration. So it is n-1 D 1 to 10 ns2. So what is the general electronic configurations of the D block element? n-1 D 1 to 10 ns2. What is this? n-1 stands here. The n-1 stands here, which indicates that the electrons are present in a penultimate shell, not in the ultimate shell. Okay, the electrons are present in the penultimate shell, hence it is known as n-1 D 1 to 10 ns2, where in the d orbital you can fill the electrons up to 10, whereas in the s orbital you can fill the electron from 1 to 2, you can say. Okay, so this is a general electronic configuration. We will discuss with the 10 elements which is present in a 3D series. First I will go with the scandium, okay, which is having the atomic number 21, and the general electronic configurations will be goes like this, that is argon. So argon in the sense which is having the general electronic configurations of what? 18. Is it right? And you can write that organ electronic configuration also. That is 1s square, 2s square, 2p6, 3s square and 3p6. Is it right? So there are 18 electrons will be there in the organ. So that is why I have considered the organ as a constant. So organ 3d1 4s2, where you can see that electrons which are occupying in a penultimate shell. Is it right? So after 3p, we have filled the electron to the 4s, then to the 3d. Is it right? So hence, which is known as the last electrons which is enters to the penultimate shell, hence they are known as what? D block element. You can see that last electron which enters to the penultimate shell of the 3d, and here in the scandium, one electron which goes to the last shell, that is in the penultimate shell, hence it is known as what? One unpaired electron which is there in the d orbital, hence it is example for the d block elements. Clear? Titanium, which consists of 22 electrons. So how we will write the electronic configuration again? Organ 18, 4s2, remaining electron has to be filled to the penultimate shell. So I'll fill the 2 electron to the 3d2, because in the 3d we can fill the electrons up to 1 to 10. Is it right? Hence I have filled the 2 electron there. So it is 3d2, which indicates that the d orbitals which consists of 2 electron, or you can write the d orbitals here onwards. So which consists of 1 electron. Similarly here, how many electrons will be there? So there are 2 electrons will be there in the d orbital. Similarly, I will go for the vanadium, which consists of 23 electrons. So I have filled the organ, then to the 4s, then to the 3d, which consists of how many electron? 3 electron. Okay. So similarly, I will go with the chromium, which consists of 24 electron, and electronic configurations will be organ 5, 4s1. It is an exceptional case where you can see that I have filled the electron in the chromium, which consists of 24 electron. You can see that I have filled the electron first to the organ, then I have filled only the 1 electron to the 4s, then I have filled the 3d 5 electron. How do you fill the electron? So it consists of 1, 2, 3, 4 and 5. Okay. Again in the 4s, we have 1 electron which is unpaired. So this is the exceptional cases which is there in the 3D series. More about this you are going to study in the next concept. Next we have manganese, which consists of 25 electron. Again the electronic configurations will be goes like this. So first I will fill with the organ, then s orbitals which consists of 2 electron, whereas the 3 orbitals which consists of 5. So it is 5 electron. Okay. Then next is iron, which consists of 26 electron. Under that argon has got 18, then 4s has got 2 electron. Similarly 3d has got 6 electron. So how do you fill this electron? So each atomic orbital has to get 1 electron, and the remaining electron has to be get paired up according to the Hund's rule. Okay. Next we have cobalt, which has 27 electron, has argon has got 18, whereas 4s has got 2 electron, whereas in the 3d it has 7 electron. Again fill the electron according to the Hund's rule. So 1, 2, 3, 4, 5, 6 and 7. So fill the electron to the each atomic orbital, remaining electrons has to be get paired up. Okay. Next we have one more element, nickel, which has a 28 electron, and electronic configurations will be goes like this. It is 1, 2, 3, 4, 5, 6, 7, 8. Okay. Similarly, we have copper, exceptional cases, which has 29 electron. And how do you fill this electron? So we fill this electron, I'll write it here. 1, 2, 3, 4 and 5. So again we have 1 4s. So it consists of 1 electron in 4s, and in 3d which consists of 10 electron. So 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay. So the 3d orbitals which is completely filled in case of copper. Zinc now, which consists of 30 electrons. So how do you fill up here? So again you can see that all d orbitals which is completely filled. Is it right? All d orbitals are completely filled. That is why I have explained that zinc as well as with the cadmium as well as with the mercury, even though they are not behaving like a transition element, they have placed in a transition series. Because in a d orbital you can see that all the atomic orbitals are completely filled. So it is not behaving like a transition series or transition element, but it is kept in a periodic table. So we have seen that there are two exceptional cases. One is chromium and the one is copper. More about this we will discuss with the next concept. Okay. So hope you understood with this electronic configuration how to write with the d block element. Always remember, when we are writing the electronic configurations of the d block, last electron should go to the penultimate shell. What does that penultimate shell indicates? Penultimate shell in the sense it is a shell which is present next to the vacant site. Next to the valence shell, the back side which shell which is there, that is known as what? Penultimate shell. Here also in the d block, we fill the electron in such a way that last penultimate shell has to get the electron. Okay. Hence it is known as n-1 d 1 to 10 and ns2. Why we have written n-1 here? Because the electrons which comes to the penultimate shell, which means that electrons which come back to the back side of the shell, hence it is n-1. Okay. Next, we'll see the general electronic configurations of whole transition series. I'll go with the first transition series, that is a 3D series, which are having the atomic number from 21 to the 30 and it has a subshells of 3D, and you can see that the last 10 electrons will go to the 3D orbital. So the general electronic configuration is argon 3D 1 to 10, 4s2. So just now we have discussed with from the scandium to the zinc. And if you go to the second transition series, which consists of the atomic number from 39 to the 48, it has a subshell of 4D and it has a general electronic configurations of krypton 4D 1 minus 10 5s2. Okay, you can see that again the last electrons which goes to the d orbital. You can similarly see with the 5D series also, which is nothing but a third transition series, which are having the atomic number from 57 to the 80 and which having the 5D, which is the last penultimate shell, and the electronic configurations will be goes for the 57, that is xenon 5D1 6s2. From the atomic number 72 to 80, we have a general electronic configurations of xenon 4f 1 to 14, 5D 2 to 10 and 6s2. Similarly, we have fourth transition series, which is nothing but a 60 series, which are having the elements with the atomic number 89 to 104 and 112, which has a general electronic configurations of 89, radon 6d1 and 7s2, and the elements which are having the electronic configurations of 104 to 112. In that, you can see that it has a general electronic configurations of radon 5f 1 to 14, 6d 1 to 10, or with the 2 to 10 and 7s2. You can clearly understand that the last electrons in these two, that is in the 5D as well as in the 6D series, the last electrons which goes to the F orbitals, is it right? Hence it is known as what? F block elements. Okay. Next we have characteristics of the transition elements. Except mercury, which is a liquid at room temperature, all other elements are solids and they exhibit all the characteristics of the metal. So at the beginning only I told you that, so the D block elements, all the elements are behaving like a metal except mercury, because we are familiar with the mercury where we are using in our thermometer, which exists as a liquid at room temperature. Okay, and they shows a variable oxidation state unlike S and P block. So in the S block element, we are familiar with the group 1 and group 2 where it has a +1 oxidation state, whereas the group 2 it has a +2 oxidation state. But when we compare the S as well as with with the P block, this D block element shows a variable oxidation state. Again, that oxidation state also you are going to study in the next session. And there are some of their compounds shows the catalytic property. It is very important. Some of the compounds of the D block elements, they behave like a very good catalyst during the reactions. Hence, they shows the catalytic property also. And their compounds are also having a color. The compounds are also having a different colors. Hence, this is another important characteristics. And they have a greater tendency to form a complex compound, and they form some alloy as well as with the interstitial compound. So you will understand how does D block elements which forms an alloy as well as with the interstitial compounds in the next concept. So hope you are understood with the general characteristics of the transition elements. Remember, they behave like a metal and they have a catalytic property and they can form an alloy and they can exhibit in a solid state and they can form an interstitial compound and they form a many number of complex compounds. Okay, and this shows what? Variable oxidation state. Again, in the next session, we are going to understand general characteristics of the transition element. Under that, more about the general characteristics as we have discussed in case of classifications of the element. Same thing like atomic radii or ionic radii, we are going to discuss in the next session. So by this, I like to say that what are all the things which I covered in this session, it's just an introduction to the D block element along with the electronic configuration. Especially with the electronic configuration, have a look on it, because in the 3 marks, they can ask you to write the electronic configurations of the any D block element as well as with the F block element. Okay, so we'll meet you with the next session. Till that, take care, be safe. Thank you.